Hey everyone, welcome back to the channel. This is Rahul. In today's video, we are going to solve an important dynamic programming problem from LeetCode, that is shortest common supersequence. This problem is commonly asked in FAANG interviews, and understanding it will sharpen your dynamic programming skills. So make sure to watch till end. In this video, we will cover problem explanation, different approaches, then from that, we will take the optimal approach, which we will use LCS, that is longest common subsequence and dynamic programming. Then we will write one efficient Java code and I will explain it line by line. At last, we will analyze it complexity and we will discuss why this one is efficient compared to other. So if you are new here, subscribe my channel for more DSA contents and coding videos. So let's start. Here is our problem. Here the problem states that we are given two strings, string 1 and string 2. And we need to return the shortest string that has both of them as subsequence. A subsequent means we can delete some characters without changing the order. If you go through this example, ABAC and CAB, these two are included in this one. Means here CAB and ABAC. Here ABAC is a subsequence of CABAC by removing the first letter C. Like CAB is also a subsequence of CABAC by removing the last A and C. Okay, so that's the thing. In this one, since both the strings are same, the shortest common supersequence is just the string itself. So now let's talk about different ways to solve this problem. First one is brute force approach. As you know, once we the one way is to generate all possible supersequence and we need to find the shortest one. But it will create exponential time complexity, which is 2 raised to m plus n. M means length of string 1, n is the length of string 2, which is extremely slow, means it's not efficient. The second one is we will use the longest common subsequence and dynamic programming. So which means instead of trying all possibilities, we use LCS to find the common part of both strings. Then we build the shortest supersequence efficiently. Actually, this will run in big of m into n time, which is much faster. So let's dive into the code. Here we have our solution class solution with the method shortest common supersequence with two input method inputs string 1 and string 2. First of all, we need to initialize an empty string in order to store the final result. String result. So as an empty string, we don't need to give anything else. Now we will give one try catch where we will use multi-threading to compute the solution in a separate thread. Okay, so try. So here we will create a callable task that will compute the shortest common supersequence. So callable type string task. So here we are using the lambda method. Generate LCS of string 1, string 2. So here we call the generate LCS to get the shortest common supersequence. So once this done, we need to we need another one, future task, that is used to execute the task in a separate thread. Okay, that also string type future new future task. Now we need to start the computation in a new thread. So once we've done this, we need to wait for the computation to complete and store the result. So we have to update it, update the result future dot get. So that's in try. In catch, we no need to give anything special. Just um, it will catch any exception that might occur during the computation. So catch exception e. Okay, and at last we need to return the computed shortest common supersequence result. Okay, now we need to build the LCS table with which is the generate LCS method. So public string generate LCS. We will use the two inputs string 1 and string 2. Here first of all we have to take the length of both the string. That's the first step. So we will use two variables m and n. So string 1 dot length. Okay, now we need to create one dp table in order to for the process. Here we will take the size m plus n and n plus 1, which is the LCS matrix, int is equal to m plus 1, n plus 1. Okay, now we have to fill the table using dynamic programming. For int I to 1 or equal to m I plus plus. Like this, we have to create another loop. In j plus plus. Now we have to check whether character at I is equal to character at j. m minus 1 is equal to j minus 1. Okay. Now, if the characters match, then we have to add 1 to previous diagonal value. So, LCS matrix of I j is equal to, here we need to add to previous diagonal value a minus 1 j minus 1 plus 1. Okay. Otherwise, we have to take the maximum from top or left. Else, LCS matrix I j is equal to max among the top or left. Mat dot max or left one. LCS matrix I j minus 1. Okay. Now come out of the loops. Now we need to construct the supersequence. For that, I will create two variables. Int row is equal to m and column is equal to n. And we will use string builder to get the answer. Now we need to backtrack from the bottom right of LCS matrix to construct the supersequence. So we have to give condition like row should be greater than 0 and column also greater than 0. Okay. Now we need to check if the characters are match or not. If it is matching, then we have to add to result and we need to move diagonally up left. Okay. If string1 caret row minus 1 which is equal to string2 caret column minus 1, then we have to add to result answer dot append caret row minus 1. Now we need to move diagonally up left. So decrement row and column. Row minus minus, column minus minus. Okay. Else if the uh, top left, if the top is greater than left, then we have to move up LCS matrix row minus 1 column greater than greater than LCS matrix. So this is the top, this is the left. Then we have to move up. Dot append caret row minus 1 and decrement row. Another condition is we have to move left if the left cell has higher value. Means if this condition turns, if it becomes like this, then we have to go for the next condition. Else dot append string2 dot caret column minus 1 and decrement column. Okay, so come out of the loop. Now we need to append the remaining characters from string 1. Means if any is there, we have to append. While row greater than 0, append caret minus 1 and decrement row. Like this we have to do for column. While column greater than 0, dot append string2 dot caret column minus 1. Okay, and same like before, decrement column. Once this done, we have to revise the answer that we got in order to get the correct order, because as we know it took from the last one, that's we done backtracking, so we have to revise it. Dot reverse this inbuilt method convert to string. Okay, let's run this one. Okay, yeah, so it's working fine. So you may get doubt like, Did I miss anything? So you may get doubt regarding the try catch. So here the try catch block is used in order to handle exception that may occur when executing the future task, which means here this future dot get that we are given now. Here this will wait for the result for the of the computation. If the current thread is interrupted while waiting, it throws an interrupted exception. And here we given callable string task inside the future task, which encounters an error. The future dot get will throws an execution exception. So here the try catch ensures the program doesn't crash and handles errors gracefully. So if we didn't use means use the try catch if an exception occurs like a thread interruption or execution exception, the program will crash with an unhandled exception. So because of this reason, I used try catch. Okay. So next thing you may get doubt in. Okay. So next thing might be string builder. Why I used here. So in this method generate LCS function, instead of using string, we use string builder for constructing the shortest common supersequence. If we use string rather than string builder, then actually string is immutable. If we concatenate string using plus in a loop, a new string object is created each time, which will leading to high memory usage and less performance. So it will leads to a time complexity of big of n square since new strings are created repeatedly. So that's the main reason we used string builder. As you know, string builder is mutable, which means that it can modify strings in place without creating new objects, which making it faster for string operations in loops. I hope you understand what I meant. Here, the time complexity will become big of n, since and we are not using any extra memory allocation like the string concatenation. So these are the things you may get doubt regarding this code, and if you get any other doubt just give in comment. I will reply for that. That's it. We clearly solved this problem regarding the shortest common super sequence. So if you found this explanation helpful, this code helpful, don't forget to like, share and subscribe. See you in next video. Till that, happy coding.